Assumptions for chi-square test of independence. Chi-square test of independence is a statistical test that will determine if there is any association or relationship between two independent categorical variables. So the data have to be in a categorical type, or the variable have to be categorical. The test will examine whether the occurrence of one variable is independent of the occurrence of another variable. So whether there is association between these two variables, or where these two variables are independent from each other. So the data have to be assigned in a contingency table format. So the table will show the variable frequency or frequencies for each categories. To perform the chi-square test of independence, a hypothesis have to be generated. The null hypothesis will state that the two variables are independent, i.e. there is no association between the two variables. The alternative hypothesis will state that the two variables are not independent, i.e. there is association or relationship between those two variables. And then the rejection or acceptance of the null hypothesis depends on the p-value. If the p-value is less than 0.05, then reject the null hypothesis. So the chi-square statistics will measure the discrepancy between observed and expected frequencies based on the formula given here. Chi-square equal to the summation of between two brackets to the power of 2 O minus E divided by E. So O is the observed frequency in the cell, and E is the expected frequency in the cell. So the expected frequency for chi-square statistic test is calculated as following: the total row total multiplied by column total divided by grand total. And the degree of freedom is calculated by the number of the rows minus 1 multiplied by the number of the columns minus 1. So what are assumptions that have to be fulfilled prior to performing the chi-square statistical test? Assumptions are certain conditions or criteria or characteristics about the data that have to be fulfilled or met prior to performing any statistical test to generate a valid and reliable results. So every statistical test have a set or a collection of assumptions that have to be fulfilled. Any violation of these assumptions will lead to unreliable findings from the statistical test and will lead also to incorrect conclusions. So there are 6 major assumptions that have to be fulfilled before performing chi-square independence test. The first assumption is that both variables are categorical. Categorical data are measured at a categorical level. It can be ordinal or nominal. Ordinal data is categorical data, but there is order in the data. Nominal data is categorical data with no order in it, such as occupation. So examples of categorical data: marital status is a nominal data, as there are three classes given here: married, single, divorced. Another example is smoking status, whether you are a smoker or non-smoker. It is categorical. It is binomial or binary data because there is only two levels in it: yes or no, smoker, non-smoker. Likert scale, which is commonly used in a survey or questionnaire, is an ordinal data or ordinal scale, as the data is sorted in categories but with order in it, such as strongly agree, disagree, strongly disagree. Assumption number 2 is that the observations are independent. What does that mean? It means that every observation in the data set is independent. Value of one observation in the data set does not affect the value of any other observation. So no individual or no item should be counted in more than one cell within the contingency table. The third assumption for the chi-square is mutually exclusive category. So cells in the contingency table are mutually exclusive, which means individuals can only belong to one cell in the contingency table. An individual cannot belong to more than one cell, and each category of the variable should be distinct and non-overlapping. The fourth assumption is that there should be sufficient sample size. The sample size should be large enough to provide reliable results. The fifth assumption is that random sampling, which means that the sample data should be collected randomly from the population. And finally, the sixth assumption is that the expected cell count should be equal to or greater than 5. So expected value of cells in the contingency table should be equal to or greater than 5 in at least 80% of the cells. So no cell should have an expected value less than 1. If expected cell count is less than 5, then use an alternative statistical test that is suitable for these conditions, which is the Fisher's exact test. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovie, RStatistic or Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovie, RStatistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.